Well, hey guys, Mr. Delcourt here. We're going to do a little bit of quiz prep to get ourselves ready for these second law problems where we have to determine forces and net force and um, all the various forces acting on an object in a given problem. And we've been working on these together, and I'm hopeful that you're working on your end independently. But if you need a little help, this will be a great tool for you to check in and make sure you're doing these problems right. So let's jump right in here. And let's take a look at the first of three problems. This is going to be very similar to our quiz we're taking next time. So if you're able to do these, then you are really ready for the quiz. If you're having some trouble, it's pretty important that you reach out for help or continue to practice. So if we look through here, we know step one in all of these problems is always to identify the variables we are given in a problem. And if we look here, we can see that in this example, we've got a 77 kilogram skydiver. That's the guy's mass, all right? And he's fallen for 500 feet, and he's accelerating downward at 7.5 meters per second. We want to know what is the force of air resistance on that skydiver at this moment. And look, we've got our forces already plugged in there for us. So really our job is just to follow these steps as we work our way down through and solve each. Remember, each time we solve something, it kind of opens up the next thing. So I'm going to write down my variables I know here. I know 77 kilograms. Remember, that's the mass. We actually know distance. The distance that he's fallen may or may not help us here. The distance is 500 feet. I'll write it just because. We know his acceleration is 7.5 meters per second downward, and we're solving for the force of air resistance. So jumping right in here, if we know mass, then we can solve for F-grav. That has been step one all along, and we know right up here that F-grav is equal to mass times G, little g, 9.8. So let's grab our calculator here, and we're going to go our mass of 77 kilograms times 9.8. That's going to give us a force of gravity here. So I'm going to say F-grav is equal to 77 kilograms times 9.8 meters per second. That's equal to 700. We'll round that to 755 newtons. Cool. We got that down. And so here we go. So I'm going to plug that in right over here. F-grav is 755 newtons. Our next step, it tells us if we know mass and acceleration, which are both given to us here and here. If we know mass and acceleration, that allows us to solve for the net force, the leftover force. Remember, Newton's second law right here is that the net force on an object is equal to its mass times its acceleration. If we know mass and we know acceleration, we can figure out that net force. So let's do it. Let's take our mass. F net is equal to 77 kilograms times 7.5 meters per second. And let's grab our calculator again. And we're going to go 77 times 7.5 is going to give us, let's see, we'll round that to 578. 578 newtons of net force. Now here's the key, and this is what gives people trouble sometimes. We've got a skydiver and he's jumping, and we recognize that he's still accelerating downward. All right, so that means he is gaining speed downward as he falls. So what we really know, what this number here, 578 newtons, tells us is that's the difference between these two forces. We know that one force is greater than the other by 578 newtons. That's really what we know. And if we use our logic and we think to ourselves, if we're accelerating downward, we know that the net force is always in the direction of the acceleration. If your net force is downward, then you're accelerating downward. So that tells me that the force of gravity here has to be greater than the force of air resistance by 578 newtons. So to solve for that, I'm going to take F-grav of force of gravity is 755 newtons, and I'm going to subtract that net force, 578 newtons, and that gives me 177 newtons. That tells me that the force of air resistance is 177 newtons. And there you go. We've got it. We've got our answer right there. So what we did here was 755 newtons minus 578 newtons. And that gave us 177 newtons for the force of air resistance. Pretty cool. There's our first one done and in the books. All right, let's take a look at our next one. Our next one, we've got 4 forces. It says we've got a 180 kilogram dog sled being pulled down a trail at a constant velocity. The coefficient of friction between the sled and the snow is just 0.18. And we need to determine the pulling force created by the team of dogs to keep it moving at a constant velocity. Oh, we've done plenty of these at this point. We know how to do this. What do we know? We know mass of 180 kilograms. We know the coefficient of friction is 0.18. And we know that we're traveling that constant velocity. Well, that's going to come back into play here a little bit later. So first things first, as always, if we know mass, then we can solve for the force of gravity. And remember, our equation is F grav is equal to the mass of the object, 180 kilograms, times little g, 9.8 meters per second. And here we go, 180 times 9.8. We've got force of gravity on this thing of 1,764 newtons. All right, cool. Let's pop that in here. 1,764 newtons. And here's the fun one, right? If we know the force of gravity, if we know the weight of this object, how hard gravity is pulling it down, then we automatically know the normal force, because we know that by definition, normal force is always equal to gravity. It's a supportive force. That dog sled's sitting on the ground, and the ground is pushing back with equal force to hold it up. So we automatically know that normal force is also 1,764 newtons. All right, so now our next step in this kind of problem, well, we just unlocked normal force, and if I come up here and look at my equations, I realize that, holy cow, I've been given the coefficient of friction. I now know normal force. I can solve for the force of friction. Let's unlock our next clue here. So to do that, we're gonna use our equation from up above. That's the force of friction is equal to our coefficient of friction, 0.18, times F norm, which is 1,764 newtons. And let's see what that gives us here. Let's go. 0.18 times 1,764. That gives me, we'll say, 318 newtons for my force of friction. So I'll plug that in up here. 318 newtons. All right. And this is the interesting part, right? If we come back up here, remember we're traveling a constant velocity, and it says the fact that the truck is traveling at a constant velocity tells me force of friction and the pushing force from the dogs, or really what is a pull from the dogs, right? The force of friction and that pull from the dogs must be equal. Newton's first law tells us objects at rest and objects in a state of constant motion, objects are at rest or in a state of constant velocity unless acted upon by that unbalanced force. So that's how we know all of these forces must balance out. So we know that the force of friction is 318 newtons, and that means if this dog sled's traveling at constant velocity, the dogs must be pulling it with exactly 318 newtons of force. It's all balanced, and in this case, you could say that the net force on this thing is 0. There is none, right? They all cancel each other out. Cool. We've got one more to do here. This is, we're clipping right along. All right. And this question is about Aaron, a.k.a. Aaron, a.k.a. Lorani. That's my son. He's a beast, okay? And he has a mass of 20 kilograms. And he runs and then slides down a long, icy puddle on the sidewalk. Oh, man, I used to love doing that when I was a kid, and he certainly likes doing that now. He's not being pushed while sliding. Remember, he's just sliding along. There's nothing pushing him, right? That's all Newton's first law, that law of inertia, keeping him moving down that puddle. The coefficient of friction between the puddle and Lorani is 0.12. Determine Aaron's acceleration. Remember, it's all the same guy. Lorani, Aaron, whatever you want to call him. So we want to know what's force's rate of acceleration. I want to know, like, what's the rate and direction. We always get a direction of acceleration. So let's think about this here. What do we know? We know the mass of little Ronnie. His mass is 20 kilograms. And we know the coefficient of friction is 0.12. And boom, step one always. Let's take the force. Let's figure out force of gravity by taking little Ronnie's mass, 20 kilograms, multiplying it by 9.8 meters per second. That's little g, gravity on Earth. And we're going to go 20 times 9.8, 196 newtons. That's how much little Ronnie weighs. 196 newtons. All right. And oh man, here comes Norm again. We know that if we know the force of gravity, we automatically know normal force. They're always equal to each other no matter what. So there's a little cheat code for us. I can just, no math involved, plug in 196 newtons up there. And it says we can now use the normal force and the coefficient of friction. We know two things. We can solve for the third. So let's take that. Let's solve for the force of friction. As little Ronnie slides down the puddle, we're going to take our coefficient of friction, which is 0.12. We'll multiply it by the force of, normal force, which is 196 newtons. Let's do it. 0.12 times 196 is 23.52. Let's round that to 24, equals 24 newtons. All right, force of friction is 24 newtons. Cool, that's not that much. So now we can figure out, all right, so we know all our forces. It says I can now use my completed free body diagram to determine the net force. And if we know all our forces, first thing I do is look vertically, right? I look up and down. And I see 196 up, 196 down. Those cancel each other out. Okay, now let's check left, right. I see 24 newtons to the right and no force to the left. We've got an unbalanced force, and in this case, the math is easy. The only force is those 24 newtons to the right. So our net force, F net, is equal to 24 newtons to the right. That's pretty key. So now our final step here, if we know net force, which we just figured out, and we know little Ronnie's mass of 20 kilograms, that allows us to solve for acceleration. Newton's second law, right here. The net force on an object is equal to its mass times its acceleration. We now know this, and we know this. We can isolate that, the acceleration, and figure this all out here. So let's do this, right? Net force on little Ronnie is 24 newtons, and that's equal to his mass of 20 kilograms times who knows what his acceleration is. We need to solve for that. So here we go. We got to get A all alone. This is algebra stuff, right? So I'm going to divide both sides by 20 kilograms to cancel that out. And here we go. We can go 24 divided by 20 is going to give us 1.2. So it's going to be acceleration is equal to 1.2 meters per second, right? Because we're talking about acceleration now. And we also need to give a direction. And we know that if our net force is to the right, then we must be accelerating to the right. And in this case, we've done several problems like this now. We know that little Ronnie is actually slowing down. He's moving to the left, but he's accelerating to the right. He's just slowing down, and he's slowing down at a rate of 1.2 meters per second. So we could put that in there. He's slowing down. I hope this little video tutorial has been helpful to you guys, and I'll post the answer key up there with the assignment as well for you to take a look at. But feel free to reach out with any questions you may have, and I look forward to seeing you guys next time.